Welcome to Cloud on Air, a live webinar from Google Cloud. We're hosting webinars every Tuesday. My name is Kevin Ford, and today I'll be talking about API security. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's get started. So we have a lot to cover today, but we're going to be looking at an overview of the Apogee Edge platform, which is Google Cloud's API management solution. And we'll talk specifically a lot about API security and the things you need to consider as an API provider. Then I'll take you on a deep dive into Apogee Sense, which is a feature of the platform that provides bot detection and behavior-based detection. And then we'll go on to a demo of that particular feature, and then we'll move into Q&A. So first, let's look at a high-level overview of Apogee Edge as a platform, and then we'll dive into some security features. So one thing that we see as a repeated pattern of success when we work with customers is taking an outside-in approach with their APIs. So traditionally, a lot of customers traditionally in IT shops think of APIs as an exposure problem. You know, build the API and consumers will come and use it and everything will be, straightforward. And that doesn't always happen. What we find is a much more successful programs end up thinking about how to deliver that experience to the user. So who do we need to enable here? In this slide, you see the developer. This is the developer building your systems of engagement, building your mobile applications, your web applications. You need to enable them to have, with a great API that's consistent and easy to use, so they can build those experiences and iterate on them very quickly. And you do that with an API platform that offers features for your API team to move very rapidly and respond to the needs of that developer. So we're going to focus on, in the Apogee platform, helping with exposure, but with a deeper focus on consumability. And that means just a great developer experience overall. So this is a high-level look at the capabilities of the platform. It's one single unified platform with a single experience for your users, but it can be thought of as being in three conceptual parts. So API services hosts your runtime, and that manages all your API traffic. That's where you would apply all the API features and policies like traffic management and security that we'll get into. Developer services is where you host a portal as a primary feature, and then that enables all of the other experiences that the consuming developer will have when they interact with your API program. And then analytics services to give you the ability to measure the program from end to end. Management services really is the foundation on which all of them are built. So first, API services. Here you can see a super high-level overview that shows where the platform sits. And the Apogee Edge runtime sits in between your API consumers and your back-end systems. And this facade pattern allows you to extract or abstract a lot of the cross-cutting concerns that you would typically be building into your back-end services, things like security, throttling, managing SLAs with particular clients. All of these types of things that you have to do for all of your API consumers, you move those into the platform, and then that frees up your service developers to focus on building services that are related to their domain expertise, and they don't have to worry about implementing all those cross-cutting concerns. So now moving on to developer services. At the heart of developer services is a developer portal. And this is what you see if you go to any API provider and you want to consume their API. If you go to Google's developer portal, you'll see a listing of all the APIs on offer. You'll have the ability to try them out. You can kick the tires. You can see descriptions of what it requires to interact with the APIs and what they can do. All of these things make it very easy for you to consume our APIs. And you should be thinking the same way about your own APIs. Think of them as products. And you're marketing these products to developers who are going to consume them. And especially in the case where there are alternatives, you need to make that a really good experience for those developers so that their time to first response is very short. often measured in seconds. So as an API consumer, if I go to a portal of an API provider and I can't, within a very small number of minutes, get a successful response and try it out, hopefully in a live trial situation, then I'll move on somewhere else. So having that world-class developer experience is really important. Additionally, in the developer services, we host things inside your portal like a forum, blogs. We can host SDKs, all of the typical things that API consumers expect to help them leverage your APIs and be successful. And then finally, analytics services. So you've built out your APIs. They're being consumed, hopefully, by a lot of developers, both internal and external. So how do you measure the success of your program? How do you know which APIs are experiencing greater than expected latency? Are there high error rates for particular APIs? Is that a problem with your API documentation, your backend, or is it an issue with the client? So with Apogee Analytics, we provide you insights all the way from the client consuming app to your backend service. So you can see everything along the entire chain and be able to evaluate and make business decisions about which APIs to promote, which APIs might need work, and as well as operational insights for working on performance and these kinds of things. So every year, Apogee hosts an API conference where we share our thought leadership on the API landscape and API space. And we have business and technical tracks. And we actually started this year's in Sunnyvale a couple months ago, and coincidentally today, we're wrapping up the world tour in Chicago. But on our technical track, we're always talking about the aspects of an API program that make us successful. When you look at the actual APIs, a lot of the things that make them successful, like I mentioned before, making them easily consumable by developers, are things like having a standard consistent interface. And you get that by applying that facade and not leaving the interface up to each individual service developer. The fact that there's a consistent resource model to code against. All these things that make APIs easy to use also make them very easy to use by attackers who want to exploit vulnerabilities in your backends. So what kind of tools do you have if you're leveraging Apogee in order to combat some of these attacks? So this picture shows an end-to-end view of the kinds of features we have in place to help protect your APIs. Starting at the client, we have the ability to leverage TLS, of course, one-way or two-way TLS between the client apps and Apogee itself. We have OAuth policies to enable OAuth protection, API key policies, JWT policies, all out of the box. I'm not going to get into all of this and read this whole slide. There's a lot of features, but at the proxy level, we have similarly, we have access control, OAuth. We protect the backend as well with TLS, IP whitelisting, and then the platform itself has full role-based access control, both in the platform for your organization's users, as well as in the developer portal. So when a consumer comes, they see the right API products, the right APIs, the right level of access that you want them to see. And you may have a different view for your the developers internal to your organization versus external third parties. So all of that end-to-end is all done through configuration. There's no code. This is configuring features or drag and drop with policies to do all this enforcement. So there are lots of attacks, and we hear about these all the time. There was a pretty bad breach just about 2 weeks ago where a major social network ended up allowing the harvesting of hundreds of millions of user accounts. So that's an attack that falls into one of the major two categories we see. And there are more categories in this, but the vast majority of them go into account takeover type attacks and scraping attacks. So the one I was just discussing is a scraping attack where a vulnerability which allowed more access to more resources than was intended by the platform allowed a malicious application to scrape far more data out and then retain that data and use it for its own purposes. So all these attacks are things that you need to be concerned with, and they're all things that we're seeing across a broad range of our customers. Very few of our customers that we've evaluated and worked with have not seen a large number of these attacks occurring live on their APIs. So this is a quick graphic here to sort of demonstrate a couple of the different kinds of attacks. And first, we're all familiar with denial of service attacks. And as a GCP customer, you're already leveraging a massive data center bisection bandwidth in excess of 1,000 terabits per second. So from a DOS perspective, you're being protected by a cloud provider that's able to absorb an immense amount of traffic. But there are other kinds of attacks. So if you look at here, we've got the ability to do volume-based and region or blocking based on known bad ISPs or IPs, and that'll block that'll block your DOS attacks. But a lot of things will still get through because these malicious bot creators know how to stay kind of under the radar. They know that if they send millions of requests a minute, this will be blocked. They also know potentially that you have, because you have a developer portal that says so, that you allow 500 requests an hour. So we see bot writers creating bots that come in at a randomized number of requests, say between 4 and 450 requests. So it looks and blends in with your normal traffic. So it's important that we have a different way to address these types of attacks that look like human traffic. So it ends up that the security model is very different with APIs than it is with traditional systems before we started exposing our APIs in such a wide way with external entities. So you need protection that's purpose-built, and it's going to separate the bad from the good traffic, both from your good clients, because you need to, for a known partner of yours, they'll still make bad calls. For instance, exceeding a quota, we need to block that. For instance, issuing a request with an expired API key, you need to block that. But then there are all these bad actors as well, and it's very difficult with those types of calls to distinguish. And that's where we introduced Apogee Sense. And this was in response to a lot of our customers experiencing high volumes of bot traffic. And they came to us and said, this is difficult because we have set up quotas. We've established all of the right things, but those requests are still coming in. And although they don't always penetrate the system, we can see through our analytics that they're there, those requests are there. And they wanted us to help them address this. So how does Sense work? So as I mentioned, it's built specifically for APIs, and we've leveraged the fact that we process trillions and trillions of API calls to learn what are the bad behavioral patterns. And this is, again, not a deterministic, this one particular call is exhibiting this behavior. It's more about, over time, this particular IP, particular ISP, set of IPs is exhibiting this behavior. And that is something that we can detect. And it happens in a closed loop, and it gets smarter and smarter as you use it and as you apply rules as you feed rules into the system. So Sense runs in the background, and it leverages the analytics data that we're already collecting. So there's very little overhead. We've built the models for detection based on our understanding of all of our customers on our cloud. However, your data as an individual Apogee customer is never commingled with anybody else's data, any other customer's data. Our tenancy model disallows that, but we have leveraged the fact that we're the largest API management platform to gain insights about what kinds of patterns matter and how to protect against them. So of note also is the patterns that I mentioned, and we'll look at them in a minute in the demo. We've established the patterns, but they're completely tunable by you. So you start out with sensible defaults, and then you can tune them by you, and you can even introduce your own rules and patterns. So Sense operates in two high-level phases. There's detection and protection. in detection, as I mentioned, the traffic's analyzed in real time, and the alerts, when we detect suspicious behavior, and I say suspicious, we don't know when we detect something that it is bad traffic, but we know that it matches a pattern that we suspect might be bad traffic. So we issue alerts immediately to your administrators, and then they come in and they get a full detailed report that shows the types of attacks that are coming in and the behaviors they're exhibiting. You can dig into the logs and analyze exactly what the requests look like. And that gives your operational administrators and your security admins the ability to detect or to start thinking about how to act on that traffic. So that's phase one. And I mentioned we'll look at some of the rules, but we have rules about unusual error rates, accessing a larger than expected surface area of your APIs. If you have a catalog, for instance, in the retail space, it's atypical for a customer to access 60% of the items in your catalog. That would be a trigger for a bad behavioral pattern. So the next step is protection. So now we've given you this dashboard, and we've given you alerts to let you know that we have suspicious activity potentially happening. So you'll see a dashboard where you can then act on all of these requests, and you can choose, and this is a big differentiator here, is you can choose to allow that traffic to proceed into the system, you can choose to block it, or you can choose to flag it. And this gives you a really flexible way of handling the traffic. And we'll dive a little more into what I mean by that flexible protection. But just lastly, I just want to just drive home this closed loop. So the closed loop system that we've implemented does a couple of things. One is because we're leveraging analytics data that we already capture anyway, we add very little, almost no latency to requests. In fact, we add no latency at all to detect. We add less than 10 milliseconds of latency when we are protecting. And that's a matter of if you want to block or allow or flag traffic. So it's a super low latency solution because it runs in a closed loop offline with data we're already collecting. And a little more on flexible protection. There's two things we mean when we talk about flexible protection. One is what you can do. What kind of actions can you take? I mentioned that you can block traffic, you can allow traffic, or you can flag traffic. So what is flagging? What that means is adding a header, for instance, to a request to say, maybe I don't want to block this immediately. I'm aware that this is a bot. I'm aware they're scraping my data. But instead of blocking them so they can go and retool their bot and hit me again, I might want to send them a delayed response. I might want to manipulate the data. I can manipulate the data in the request. I can send them static pricing data. I can dummy the data up. I can remove fields from it. There's all kinds of things I can do to that data. And that's a really powerful tool because the bot developers are looking at their responses. So sometimes blocking is the right choice. Sometimes you want to do something specific to handle that in a different kind of way. And allowing is another important aspect because we allow our partners to work against our APIs in a bot-like way. I have many customers who have partners that write bots to pull down data on a daily basis. So that would appear to Apogee Sense as a bot, but your security admins can go and allow all of that traffic for its particular duration or perpetuity so that that partner is not, his traffic's not blocked. So the other aspect of flexible protection is configuration or code. So the first that I mentioned is how you act on your traffic. And then the next one, the next part is specifically about the case where you flag traffic. As I mentioned, we're going to enrich the request with a header that means once that request gets into the Apogee processing runtime, you have the ability to do anything you like to it. That means you can leverage one of the nearly 40 policies in Apogee to do things like traffic shaping, conditional routing, and all of these things are done simply by configuration. It's a policy that you drag into your API flow, you tune the attributes, and it works. The other choice of how you deal with flag traffic is through code. And we have extension policies that allow you to write JavaScript, Python, Java, or Node.js if you want to extend the capabilities for handling that flag traffic. So it gives you a lot of different flexible options on how to deal with these potential attacks. So I have a graphic here, and I want to talk a little bit, sort of the way I think about API security is it's about layers of defense. And the best analogy that comes to mind for me is this here. If you look at this castle, and imagine for a moment that the walls here are your API policies. Your walls are defining that OAuth 2.0 is required to enter, right? So they're going to block those requests. You've got some throttling going on because you have this one defined entry point with a solid door, maybe guards in the gatehouse. And it looks pretty secure, difficult to penetrate. But there's a problem here. The problem is all around the castle are trees, and there's limited visibility. So at any moment, there could be many attackers under the tree line chipping away at that brick wall. And they may never make it through, but if you give them enough time, the odds are that they will. So just because you've got strong walls and a defined entry point doesn't completely protect you. You need visibility. So here's a different view. It's a similar castle. There's a throttling mechanism that brings traffic into one entry point with a strong gate. You've got the same walls with the same OAuth protection, but they have a moat, and they've cleared out all the trees. So you can see this API provider can see for miles as people are attempting to come in and attack, right? And that gives them the ability to figure out how to respond to them, right? If it's a friendly party, no worries. You might want to block that party, right? So it's kind of the way I think about it. It's layers and layers of security. And the Sense feature that we're talking about a few slides back is an additional layer beyond the DOS protection you get in GCP, beyond the full suite of security policies already offered by Apogee Edge, to handle that traffic that looks like human traffic or looks like friendly traffic, but is not. And then, of course, protection. We mentioned detect, with the visibility helps us with that, and protect. So as unfriendlies are approaching, we know exactly how to deal with them. All right, so at this time, I'm going to jump into a quick demo of Apogee Sense to show you what the dashboards look like and how you might interact with them. All right. Okay, so what you can see right here is the Sense dashboard, and right now we're on the detection, the bot analysis report. Let me switch into the rules and show you what those look like. So I mentioned that we have a lot of rules baked into Sense that are designed and actually were built based on the trillions of API calls that we receive and our deep experience working with all of our customers. So we have things like content quota exceeder, OAuth collector. I mentioned scraping. We have content scrapers. We have guessers. I mean, each one of these is combating a particular type of bot that generally fall into a few categories. But let's look at a couple of these. So OAuth collector, and you get a description here. It's a high number of OAuth sessions, but a small number of user agent families. So here you can define the ranges of what's acceptable or what's expected behavior. And I can define these ranges for that rule, and that rule will simply control with those new defined parameters when suspicious activity is highlighted, or when activity would be highlighted as suspicious and I'd be alerted. And the policies are all similarly configured. They have different levels of attributes for each one and different minimums and maximums in their ranges, but they all effectively follow this pattern where it's an established set of attributes and you configure the range that defines suspicious behavior. You also have the ability to create your own rules. If there are specific attacks that are relative to you, or you feel you want to investigate a particular area of concern, you can build your own rules as well. The next, I can look at the report. Detection report, as I mentioned, again, I'm gonna just to remind the audience, it's about detect and protect. And the first section, which is where we still are right now, is about detection. I want to look at a report of what's going on in my platform, and a little issue here. Just let me refresh the page. Get in the right organization. All right, here we go. So over here, I can see the total traffic that's coming into my system over this particular time range, and I can adjust my time range. And I'm showing all of them. I can filter by the requests that are already defined to be allowed, blocked, or flagged, or ones that I've not taken action yet. So at this point, I can see the kinds of behaviors that Sense is detecting. It's detecting one guesser bot, a login guesser, an OAuth abuser, and an OAuth collector. And this is the traffic from each of those. I can directly act here, which allows me to build a rule, a protection rule, to enforce a particular action on these types of requests in the future. I can dig into the details of them if I like. I can even look at a list view, which shows particular requests. This is a particular IP address, its activity over the time range that we've set, and the types of rules that it's triggering. And here I can also act on it, which will create a rule for me. So that's the detection side. Now if I look at protection, again, let's look at the protection rules that are already established. And these are ones that have already been set based on suspicious activity that Sense has highlighted to me. So these rules have been created. I can add rules, I can filter them, and you can see exactly the definition and how long they're lasting. This is a short-lived rule that'll last for a few hours. This one will always be there because it's my trusted partner. I don't expect them to change. If they change, I'll work with Sense to configure the rule for them, but I want my trusted partner to always come through with their friendly bot. But I can create a rule, and I can block traffic. I can have it expire whenever I like, and I can block by bot reason. Let's block all brute guessers and have that expire in 12 hours. And yes, it's active. Sorry. Block brute guessers. So I've created that rule, and from this point forward, Sense will automatically and instantly enforce this blocking rule. Now, had I made a flagging rule, what Sense would do is add that header that I can then go modify my Apogee API to respond to that header in a particular way. So that's a quick run through. There's a lot more I could show you of Apogee Sense, and of course of the entire Apogee platform. But in the time we have, hopefully I covered sort of the end-to-end flow of how Apogee Sense works. So I'm going to hop back here. All right, sorry about that delay. So hopefully this session was informative. Hopefully you learned a few things. If you want to learn more, there are lots of ways to do so. So first and foremost, Apogee offers a free trial where you get unlimited use of the platform, and you can spin up an organization which is the high-level Apogee unit of tenancy. You can think of it as your company, and you can spin that up in a matter of seconds. And you can then go ahead and create API proxies and start proxying your own services or third-party APIs in no time. We have hands-on enablement as well. There's a virtual API jam where it's a video instruction course where you'll have an instructor lead you through a series of labs and workshops that take you through the end-to-end journey of an API provider. And we also offer on-site API jams where we do the similar thing, but we come to you or invite you to one of our offices with your team. And then product demo webinars like this one and others. We've got a lot of features covered, and we're going to continue to cover more features based on the feedback we get from you all to these types of sessions. So stay tuned for live Q&A. We'll be back in less than a minute. Welcome back. So I wanted to do a quick recap before I jump into the Q&A. We covered Apogee as a platform. We talked about a lot of the API security threats that we see every day when we're dealing with customers. And this involves standard API security policy type things such as enforcing OAuth, enforcing your AAA type authentication, as well as traffic management, quota management. We talked about bots, both good bots from trusted partners as well as malicious bots. And then what features in Apogee Edge allow you to address those different concerns. And then we drilled down a little bit into Apogee Sense, which is our bot detection feature. And I gave a quick demo of Apogee Sense that shows how you can detect bots flowing through your APIs and how you can act on those, either blocking traffic, allowing traffic, or flagging traffic for special handlings, like redirecting to a honeypot. So now I want to jump into some questions that we've gotten throughout the session and that are coming in. First, what is the performance impact of Sense on API traffic? So I touched on this briefly. I mentioned that Sense adds less than 10 milliseconds. And essentially, you can think of this as no impact because the detection is all done offline and there's zero impact. The less than 10 milliseconds is simply the time it takes us to block or flag a call, which you would be performing anyway through an API policy or any type of enforcement measure. So it should feel like no latency is added at all to proxies when you're using Sense, to your APIs when you're using Sense. Next question, is Sense available for private cloud? And private cloud is Apogee's term for on-premises. We didn't talk about deployment options, but Apogee can be deployed on the cloud where it's fully hosted SaaS product, or on-prem, or we have hybrid options as well, and several other derivatives. But Sense is currently only for cloud customers, so on-prem customers are not able to leverage Sense. And this has a lot to do with the technologies we use to power Sense in GCP, as well as the performance required and the infrastructure required in order to run this kind of a system. So next was asked, is Sense a separate product or is it included with Apogee Edge? So Sense is a feature within Apogee Edge. You can talk about licensing with your account team, but it's a feature that's part of the platform, and you can leverage it as long as you're a cloud customer, and it is restricted to enterprise customers. We have different tiers, pricing tiers. So our basic, which are targeting lower volume API programs, are not able to leverage Sense, but all enterprise cloud customers have the ability to leverage Apogee Sense. Can this be added? Can Sense be added at the proxy level? And can you choose which APIs flow through Sense? So yes, you can detect, you can configure the detection rules to be API proxy specific. So if you only want to detect on your OAuth endpoint, you can configure rules to do that. And then protection happens at the organization level. Finally, does Sense look across all customer data to identify malicious patterns? So Apogee Sense, when we are building Sense, and as we continue to make Sense better and smarter, we leverage the breadth of data that we have across all of our customers on cloud. But that's solely for building the models. There's no, that doesn't participate at all when we're detecting traffic. So we are leveraging our experience working with some of the most major, some of the largest API providers in the industry to determine and feed into the models that allow us to surface what are the behavioral patterns that we should be concerned with. But once those models are defined and we're ever tuning those models get applied completely within a particular Apogee organization. And I touched on it, but just to confirm, an organization is a tenant in Apogee. So Apogee is a multi-tenant solution, and your company would likely be a single or possibly more than one organization. So the model is applied to your organization, and the detection and protection is done solely within the confines of that organization, completely sandboxed from all other data within Apogee. So your data is never commingled with any other data. All right, so that is that wraps up the questions that we received that were not already answered individually. So I just wanted to thank you all for your time and remind you to stay tuned for the next session, which is get the most out of your audit logs with these configuration best practices, broadcasting live from our New York office.